Today, we are talking about demolition, but not with a wrecking ball. We're talking about controlled demolition for your Python code. We're going to see how intentionally crashing your program isn't a failure. It's actually a super powerful tool for building really robust, predictable software.
So here's what we're going to cover. First, we'll get into why letting your code fail silently is just so dangerous. Then, we'll get our hands dirty with the raise keyword. That's our main demolition tool. After that, we'll learn how to actually blueprint our own custom errors. And finally, we'll see the big payoff, creating errors that carry way more meaning.
Okay, let's dive right in. To really get why we need to stop our code on purpose, we first have to understand the danger of code that doesn't stop when it's supposed to.
It sounds kind of weird, right? When is it ever a good thing for your program to crash? Well, the answer is pretty simple. It's good when the alternative is way worse. A loud, clear, controlled crash is almost always better than a silent, dangerous failure.
Because, the most dangerous errors are the ones you don't even see happening. Just imagine a banking app that accidentally accepts a negative interest rate. The code might just keep on running, no problem, but it's silently calculating completely wrong, maybe even disastrous results in the background. That's a silent failure, and that's exactly what we want to prevent.
So how do we stop these silent failures? We need a tool that lets us basically shout, "Stop! Something is really wrong here." And in Python, that tool is the raise keyword. This is the trigger for our controlled demolition.
At its heart, raise does one really simple thing. It intentionally stops the normal flow of your program by creating something called an exception. It's your way of telling the Python interpreter, hey, a condition has been met that makes it impossible for us to continue safely.
So why do we use it? Well, the most common reason is to validate input data, like checking for that negative interest rate we talked about. But it's also used to signal pretty much any kind of custom problem, which gives you really precise control over your program's flow when things start to go off the rails.
Now, what's really interesting here is that Python gives us a few different ways to use raise. The one you'll see all the time is the first one, raising an exception with a specific, helpful message. But you can also just raise the class itself, re-raise an error that you've already caught, or even raise an instance of an error that you created beforehand.
Let's talk a little more about re-raising, because it's a super important technique. Think of it like a first responder at an incident. They show up, they check out the situation, they log all the critical details. That's our accept block. But then they escalate it up the chain of command for someone else to handle, right? That's exactly what the bare raise keyword does. It lets you act on the error, maybe log it, and then sends the original untouched error on its way up the line.
All right, you've been listening for a bit. Time for a quick challenge to see if you're following along. Take a look at this code. What do you think is going to happen when we call check with the value 0?
So let's break it down. We've got a function, check, that takes in a value. If that value is 0, it tries to raise the string 0 error. If it's not 0, it just returns 100 divided by the value. And then we call it with check of 0. What do you think? Take a second.
If you guessed type error, you absolutely nailed it. And this is a perfect example of a fundamental rule in Python. You can't just raise any old thing. You have to raise an object that's an actual exception class, not just a plain old string. It's a really common mistake, but it's a super important one to remember.
And hey, just a quick side note to clear something up. You might have heard of a throw method in Python. It's easy to get them mixed up, but they are totally different things. Raise is your general purpose tool for stopping execution anywhere. Throw, on the other hand, is a very specialized tool that you only use with generators to kind of inject an exception into them while they're paused.
So, now that we've got the basic tool down, let's level up. Using built-in errors like value error is fine, but to make our code truly professional and clear, we need to move from using off-the-shelf tools to designing our own custom error blueprints.
A custom exception might sound fancy, but honestly, it's not scary at all. It's just a class that you define yourself, and the only rule is that it has to inherit from Python's base exception class. By doing that, you can create brand new types of errors that are specific to the logic of your own application. So you might be asking, why even bother? Well, it all comes down to one word: specificity. Instead of raising a generic value error, you can raise a crystal clear invalid email error. This makes your code so much more readable, way easier to debug, and lets you organize your error handling in a much cleaner way.
And look how simple it is to make one. Seriously, first we just define a new class, invalid email error, and we make sure it inherits from extension. We just put pass in the body because for now, we don't need it to do anything special. We just need it to exist. Then in our validation function, if we find an email without an @ sign, we don't raise a generic error. We raise our brand new super descriptive invalid email error. Anyone reading that code will know exactly what went wrong.
Okay, now for the real payoff. Creating a simple custom error is great, but the true power comes when we build custom exceptions that can carry extra contextual information right along with them.
First, we build our blueprint. We're creating a bank account error. The key is this custom _init method. We're setting it up so that when we create this error, we have to give it an account number and a message. Inside, self just lets us store those values on the error object itself. We also add a string method to give it a nice, clean printout. This means every single bank account error we create will carry that extra info with it.
Step 2 is putting it to work. Inside our withdraw money function, when we see there aren't enough funds, we don't just raise a generic error. We raise our bank account error, and we pass in both the specific account number and that detailed message. Now the error itself is holding that crucial data.
And here is the magic. When we catch that bank account error, we'll call it E, we can now access those custom attributes we created. We can print the nice friendly message just by printing E, but we can also pull out e.accountNumber directly. This makes our logging and our user feedback so much more powerful and informative.
So, let's do a quick recap. The raise keyword is your go-to tool for turning those dangerous silent failures into clear, manageable signals. Remember that re-raising lets you log an error without accidentally hiding it. And custom exceptions, they're the key to making your code way more specific, readable, and able to carry rich, useful data right where you need it most.
So I'll leave you with this final thought to chew on. Think about a project you're working on right now. I guarantee there's a generic value error or exception you're catching somewhere that could be transformed into a specific, much more meaningful custom exception. Try it out. It will make your code better instantly.